Hello, welcome to this week episode of the Weekend Algorithm. Now, in today's episode of the Weekend Algorithm, we'll be looking at golden rectangles. So, it's a problem on Hackerearth, and let me quickly walk you through the problem, and then we'll look at how to solve this particular problem. The problem goes like this: you have n rectangles. A rectangle is golden if the ratio of its sides is in between the values 1.6 and 1.7, both inclusive. Your task is to find the number of golden rectangles, and the input format goes like this. The first line denoting the number of rectangles, which I will take as the test case, and each of the n following lines, two integers w and h, denoting the width and height of a rectangle. Now, we have to print the answer in a single line, that is the number of golden rectangles. Now we have a constraint given: 1 is less than or equal to n, which is less than or equal to 10 to the power of 5. And we also have for the width and the height, 1 is less than the width and the height, which is greater than or equal to 10 to the power of 9. So this is our constraint. Now look at the sample input given and the output. So the explanation goes like this: there are 3 golden rectangles, 1 6500, 1 7000, and 1 6000. So one of these, the first one represents the width and the other represents the height. So the ratio of these two values is in between the value 1.6 and 1.7, so that makes it a golden rectangle. With that said, let us look at the algorithm to implement in order to come up with a solution that solves this particular problem. So our algorithm is quite straightforward due to the fact that the problem is quite a simple one. Now we have on our screen, at first we have to define an array variable that represents the dimensions of the rectangle. So I'm using an array in this case because the dimensions of the rectangle are 2 values. I don't want to use them 2 different int or double variable for this stuff, so I'm just making use of an array that is called dimension. So we define an int variable that is going to keep count of all the golden rectangles, and then we read the number of test cases, which should be the very first input from our input source. Now while test case is still greater than 0, we read from the input source again, and we split the values gotten from the input source into the width and the height, and we store it in our dimensional array. So our dimension array is going to point to the width and height of the particular rectangle at that point. Now we get the ratio of the width and height using the dimension array. We use the width to divide the height, and if this ratio is less than or equal to 1.7 and greater than or equal to 1.6, take note of the and, we have to increase the value of count. Then we take the reciprocal of the ratio one more time, and if this particular value again of the reciprocal meets the condition that is given above, we have to increase the value of count again. Then the next step is to decrease the value of the test cases, and then we continue with the while loop again. See, the test case appears to 0. Now I want you to take a good look at how I've indented this algorithm. You can see so clear that where we start the while loop from, I have indented, and if there's an if statement, I've also indented, just to make it easy for you to understand and easy for you to implement in your own program. So with that said, let us jump right to IntelliJ to see how I've written and implemented this particular algorithm. So right here in IntelliJ, we see a clear implementation of the algorithm that I've just explained so far. At first, we have our buffer reader that is going to be reading from our input stream. Then we have test cases, and this initial declaration and assignment of the test case is going to make sure that the program reads from the input source, and whatever is gotten from the input source, we are using our integer.pasty to convert that string back to a type of int and storing it in our test cases. Now we have dimensions. Now the int dimension is the array I told you about, and this dimension value is going to hold the width and the height of the particular array. Now we have our int count that takes record of every golden rectangle that is being come across. So we have our while test case is still greater than 0, and we want to make sure that dimensions is equal to the values of the array. So this whole statement right here is going to read from the input source, and then it's going to split the value that has been gotten from a particular line into two, which should be the width and the height of the rectangle respectively, and store inside of our array dimension. So it goes like this: array.string. Now inside of the parentheses we have radar.readline.split, and this is the biggest regular expression. So it's going to split wherever it gets to find a space, and we are mapping to int to create an int string, and from there we convert it to an array of type int. Now the next is to look for the ratio. So double ratio is dimension at index 0 divided by dimension at index 1. Since we just have two different values from our input source, so we have only index 0 and 1 for each test cases, one representing the one of these index representing the width and the other representing the height of the rectangle. So we have to say if ratio is greater than or equal to 1.6, and if ratio is less than or equal to 1.7, then you have to increase the number of golden rectangle found so far. Else, we want to make sure that ratio is equal to the reciprocal of ratio. So in mathematical term, if reciprocal of a particular number is the inverse of that number, which simply is 1 divided by that number. So I'm equating ratio to the reciprocal of ratio again. Now we have to check for this particular case again, and if it passes, we have to increment the value of complex, and then we have to decrease the test cases so far. Then we print as the number of count after the while loop has finished executing. So that is it for the program. That's just a walkthrough. Now the next thing on our list is to copy the whole of this to the Hackerearth platform and test our code. Now to the best part of the whole of the episode, we are going to test our code now. So for that, I'm going to select the Java programming language and use Oracle 14, and next is to paste the whole of everything I've copied previously from IntelliJ. So yeah, code editor right here, and then I'll compile and test at first. So just give it some time, we'll arrive at a positive test case, I believe. Okay, sample test cases is passed. So the next thing to do is to submit the code. So I'm submitting the code right now. So let me give you the explanation of why I also checked for the reciprocal of ratio at this particular point. The reason for that is that we have the question, and it states you have n rectangles. The rectangle is golden if the ratio of its size is in between 1.6 and 1.7, both inclusive. What it means is that if you check for the ratio of the width to the height and it is in between this value, then it's a golden rectangle. Now if you check for the ratio of the width and the height and it is not in between this value, you can also check for the ratio of the height and the width. So in this case, you are using the height to divide the width in order for you to get the value and determine if that rectangle is golden or not. So that is why I also calculated for the reciprocal. So it's a kind of tricky part. Now when they gave their own explanation, they didn't really have any scenario whereby the value of the height is greater than that of the width. We only have situations where the value of the width is greater than that of the height, so it's kind of tricky. At first I did it that way, the test case failed, and I had to kind of think and look at the question properly to get the concept behind it. So that is it. Now the maximum runtime of our program should be O of n, big O of n. Is not going to pass, not going to be greater than that, because our problem size is simply the number of rectangles we will be evaluating. So that is it. Now you can see that the request is accepted, and it took 2.754 seconds overall for the program to run completely. So with that, we've come to the end of this episode of the Weekend Algorithm. Please, if you are coming across this channel for the first time, or even if this is not the first time of you coming across this channel and you are yet to subscribe to this channel, please do so. Give this video a thumbs up and ping that bell icon so that whenever I upload, you always get notified. That's it. Peace out. Catch you in the next one.